Hi, this is the walkthrough for the ZipCar project done for the BUS 657 course for the spring 2010 semester. So as you can see, this is the main screen of the application. The purpose of this tool is to help managers at ZipCar, specifically ZipCar Atlanta, optimize the supply of their cars at the different lots, ZipCar lots that they have throughout the Atlanta area. So on this dashboard, what you see is on the left hand side, there's the supply screen, which is showing how many cars are available at each lot. And then the right hand screen, there's the demand map, where you can see how many cars are being demanded at the present time at each of these locations. The three different colored bars represent three different types of cars as shown in the legend. So they could be, right now we're calling them ABC, but they could be things like compacts, SUVs, sedans and things like that. So the purpose of this tool is to optimize the supply of cars and match them as closely as possible to the demand while keeping the cost down. So the cost involved here is the cost of moving the cars, and in this case we tie it to it's loosely tied to the distance it takes based on actual route calculations that you'll have to the actual route that you'll have to take to move the car from location A to location B. So the same information that is shown in the two maps are also displayed below to the bottom left, where you can see the number of cars available as well as the current demand in each location. So let me just walk you through what the manager would do once he comes to the screen. So at any given time, he has to grab the current demand from the system wherever the demand numbers are real time being updated into. In our case, we are just doing a simulation, but the real world, this would be real time demand numbers. So he would first hit the initialize button, and once he does that, the system will do a few different things, such as grabbing the current demand, which it's doing right now, grabbing the current supply numbers as well, and then updating the display maps to reflect the demand and supply numbers at the current time. After it's done that, it will then proceed to calculate a kind of 2x2 cost matrix, which it's doing now. So what it's doing here is calculating what would be the cost for moving cars from a location to another location for every possible combination of moving cars between these different ZipCar locations. So we make use of map point's route calculation functionality to calculate actual route distances and the costs associated with them, parameters for which can be customized within the map point interface. So now that the system has been initialized, you see the current demand numbers and the supply numbers here, which have been updated, and the same updates have been done to the map as well. So for example, if you look at, let's say, Emory, lot ID number 2, zip code 30322, you can see that the number of cars available are 277, which is reflected in the map as well in the supply map at the Emory location. And then the demand numbers are 354, which is reflected here in the demand map at the Emory location. So once the system has been initialized to perform the optimization, the manager, the user, would hit the optimize button. So at this point, we are using Excel's and Solver's capabilities to solve this optimization problem, setting up the problem in Solver and then using the cost matrix as its input to figure out what would be the most cost-effective and profit-maximizing way of moving cars around. After it's done that, the output you get is a set of instructions that you can see to your to the right of the screen now, where it gives you specific instructions on what cars to move from which location to which and how many of each type of cars to move. So for example, the first line says that you should move one type A car from Decatur to Edgewood, and so on and so forth. So you get specific instructions on how many cars of each type to move from which location to location. So this would result in a more optimized availability of cars for the current demand that is forecasted or is rather obtained for each location. So once the manager gets this, he would issue the his drivers the instructions to move cars in such a manner. And once that is done, or while that is being done, we simulate that here with a move button, which shows that the cars are currently being moved. And once the cars have been moved, you can see that what the new supply and demand numbers are updated both in the table as well as in the maps above. And you can see that the supply and demand are much more closely tied right now. For example, the Emery location, you can see now that the supply and demand are exactly the same. Some of the other locations may not be exactly the same because, for example, in this case, demand or supply might be more than the other, total demand or total supply. So you might have some unsatisfied customers or some idle cars in each case, but this is the best optimization that can be done at this point. So that completes actually one cycle of the use of this tool for the manager. And then what would happen is we foresee this tool being run maybe once every hour or once every 2 hours or something. And he would come back again after a couple of hours and then again go through the same sequence of events to go through the same cycle, so that as supply changes and as demand changes, this optimization problem can be run over and over again, and instructions can be issued to the drivers to move the cars accordingly, and he can have a very visually appealing way of keeping track of these things and easily identifying what the most cost-effective way of moving cars around is. So we have right now the system is handling 7 locations, but we understand that there might be needs to edit location details or add further locations in the future. So we also have an admin screen which he can go to by hitting the Go to Admin button. So in this admin screen, you can see the details for each car lot, and you have here he can input based on past history what the average demand for cars were in the past at each lot, because in this case we are simulating demand, but in the future if we have tied into real-time data, this might not be necessary. Also to the right we have the supply numbers, how many cars are available in each lot. This is again to override if there's a need for the admin user to override what is being obtained from the lots themselves in a real-time manner. So in the screen, if you wanted to add a lot, for example, he could add a lot for, let's say he wanted to add a Bughead lot, and zip code is 30326, and he enters like numbers for each car here, not only the number of cars, but he also goes and enters the mean demand for various we have different timing periods because that's how we're simulating the demand in this case. So if it's a morning, they have a particular type of demand versus midday versus evening versus night. And let's say he forgets to enter some particular numbers, he will get an error message indicating that he needs to enter those numbers. So that's done. He hits create. And you can see that the sheet has been updated to have a new location added, and we can also edit any existing locations by choosing any of the existing locations and editing the numbers there if he needs to overwrite anything. So after he's added this location, if you go back to the main screen, you can see that the location has already been added into the table, but in any case, before he starts using the system again, he would hit the initialize button, which would now grab the demand supply for all the locations including this new one, and also update the display maps, the demand and supply maps with the new location, as well as including that new location in the cost matrix, which would need to be fed into the optimization problem which solver will solve again when you hit the optimize button. So now that the initialization step is complete, you notice that there is a new Bughead location added at the very top end of the supply and demand maps. where you can see that the demand is far outstripping the supply in this case as per the numbers we entered. And then again the user would go through the same optimize and move steps that we did earlier to get a new set of instructions and move cars accordingly to satisfy demand in the best possible way. So that concludes the walkthrough of our ZipCar demand and supply optimization tool.